So in the next 2 hours or so, we will try to solve as many problems as possible related to sinusoidal steady state analysis. Essentially it is what? Phasor analysis. Okay. So on the screen you can see the first question. In the figure shown, there is the circuit A1, A2 and A3. That means what? A1, A2 and A3 are ideal ammeters. Ammeter first of all measures what? Current. Ammeter measures what? Current. In fact, the question has to be ideal AC ammeters. A1, A2 and A3 are what? Ideal AC ammeter. Now what does any ammeter measure? It will measure the current flowing in any branch. So if you want to measure the current flowing in any branch, in series with the same branch, you should connect an ammeter. Now our ammeter is what? An ideal AC ammeter. AC ammeter will measure what? What current? Please type in the chat box. AC ammeter will measure what current? RMS. Very good. AC ammeter will always measure the RMS value of the current flowing in that branch. Okay. So for instance, let's say you have something like this. Please tell me what is the reading on the AC ammeter going to be in this case. So what do you see here? We have a branch that contains a DC current source of value 5 amperes, and in the same branch an AC ammeter is also connected. Please type in the chat box what is the reading on the AC ammeter. Remember, AC ammeter will measure the RMS value of the current flowing in the branch. AC ammeter will measure what? It measures the RMS value of the current flowing in that branch. Please tell me what is the reading on the AC ammeter. Tell me fast. Come on. What is the reading on the AC ammeter in this case? Remember, the branch contains what? A 5 ampere DC current source. What is the reading on the AC ammeter? 3.53. How 3.53? Why did you say 3.53? What is the RMS value of any DC current? Okay, first of all, how much current will flow in this branch? How much current will flow in this branch? Because this branch contains what? A current source of value 5 amps. The current flowing in this branch is also what? 5 amperes. Now the question is, what is the RMS value of this 5 ampere current? What is the RMS value of 5 ampere current? Same. DC RMS value is what? Same as the DC value. Yes or no? If you have only some DC value, then its RMS value is also same as what? The DC value itself. If you have a sinusoidal quantity, then its RMS value will be what? The peak value divided by root 2. Yes or no? If you have a sinusoidal current or a sinusoidal voltage, then its RMS value would be the amplitude divided by root 2. But you cannot divide 5 by root 2 in this case. You understood, right? Yes. So the actual current is what? 5 amperes. RMS value of this current is also what? 5 amperes. So the reading on the AC ammeter is also going to be 5 amperes. Is this correct? Is this clear? Reading on the AC ammeter is also going to be 5 amperes. Okay, let me give you one more case. So once again we have a branch that has a current source, and in the same branch we have also connected an AC ammeter. This time let it be a sinusoidal current source, some 5 cos 3t plus 60 degrees amperes. Please tell me what is the reading on the AC ammeter in the second case. What is the reading on the AC ammeter? This time how much current will flow in this branch? The sinusoidal current, which is 5 cos 3t plus some 60 degrees amperes. Now what is the RMS value of the current flowing in this branch? Because it's a pure sinusoidal current, for any pure sinusoidal current or voltage, the RMS value would be what? The amplitude or the peak value divided by root 2. So this time the reading on the ammeter is going to be 5 by root 2. It is going to be 5 by root 2. So the point I am trying to get at is what? Always the AC ammeter will measure the RMS value of the current flowing in that branch. Okay. Okay, look at this case. Even in this case, we have a single branch that has what? A current source and also two ammeters, A1 and A2. A1, I am saying it is what? An AC ammeter. A2, it is what? A DC ammeter. A1 is what? AC ammeter. A2 is what? The DC ammeter. Both are connected in series in the same branch. I want you to tell me the reading on A1 and also the reading on A2. Please type in the chat box. Yes, Aditya. Aditya is here. Shiva Sainath. Dineshwaran, Gayatri, Pooja. Please tell me what is the reading on A1, that is the AC ammeter, and also what is the reading on the DC ammeter, which is A2. I already told you, right? AC ammeter will measure what? AC ammeter will simply measure the RMS value of the current flowing in that branch. DC ammeter will measure the DC current flowing in the branch. Remember, DC current is same as what? Average current. Yes or no? DC ammeter will measure the DC or the average current flowing in that branch. A2 8 amps, correct. Yes, DC ammeter will definitely read or show up a value of 8 amperes, because 8 amps is what? DC. The other component of the current is what? Pure AC. For any pure AC quantity, the DC value is going to be 0. So for the first term, there is what? 8 amps. DC is what? 8. For the second term, 6 root 2 sine something, the DC or the average value is going to be 0. So the net average value will be what? Average value of this term plus the average value of the second component. So DC ammeter, yes, it will read, DC ammeter will read what? 8 amps. Now my question is, what is the AC ammeter going to show? Or what is the reading on the AC ammeter? Tell me. At least one of you should be able to tell. 10 amps. Dineshwaran is saying 10 amps. What about others? Others also, please give your answer. Whether it is right or wrong, doesn't matter. Please give some answer. It is 10 amperes. Okay. See, I told you what? 8 amperes component, RMS is also what? 8. And for this component, that is what? The second sinusoidal component, the RMS value, is it not amplitude divided by root 2? Amplitude is what? 6 root 2 divided by root 2, which is what? 6 amperes. So RMS value of the DC component is what? 8 amps. RMS value of the AC component, that is the sinusoidal component, is what? 6 amperes. The overall RMS value will be what? Square root of this RMS squared plus this RMS squared. Yes or no? So will it not be square root of 8 square plus 6 square, which is going to be 10 amperes. Yes, so AC ammeter will measure the RMS value of the current flowing in that branch. I hope this part is clear. And also ideal ammeter will behave like what? Short circuit. Ideal voltmeter will behave like an open circuit. You know these two trivial things, okay? Ideal ammeter is short. Ideal voltmeter behaves like an open circuit. Now let us get back to our actual question. So here in this circuit there are 3 ammeters. All are ideal AC ammeters, A1, A2 and A3. In fact, A1 behaves like what? Short. A2 also behaves like short. A3 also behaves like short. So if you just imagine that A1, A2 and A3, all 3 are short circuits, don't you all agree that the sinusoidal input voltage source, the capacitor and the resistor all are going to be in parallel? Because the 3 ammeters will behave like what? Short circuits, since they are what? Ideal ammeters. So once you replace the 3 ammeters with short circuits, clearly we can see that all the 3 elements are in parallel. The source, the capacitor and the resistor, all 3 are in parallel. So what is same for all the 3 elements? Current will be same, okay? In fact, capacitor will draw some current from the source. Let that current be I2. Even the resistor will draw some current from the source. Let that current be I1. And the source will supply a current to this RC network. Let that current be I3. So do the directions make sense? Do the directions make sense? Look at this. I3 is what? The current drawn from the source, and that will divide into what? That will get divided into 2 parts. One part will flow through the capacitor as what? I2. The remaining current will flow through the resistor as what? I1. You understood? So I3 is what? The current through ammeter A3. I2 is what? The current through ammeter A2. I1 is what? The current through ammeter A1. And it is already given that A1 reads 5 amperes. Okay. So I1 RMS value is what? 5 amperes. And it is also given that A3 reads 13 amperes. That means the RMS value of the current I3 is what? 13 amperes. Now you should find the reading on A2. What will A2 do? Will it not measure the RMS value of the current I2? Yes. So the question is about finding the RMS value of the current flowing through the capacitor. That is the question. As I already said, all the 3 elements are in parallel. They'll have the same voltage drop. Yes. So let that voltage drop, be some capital V. Let the voltage drop be some capital V. So this V is what? The drop across cap. It is also a drop across the resistor. And remember, I'm using capital letters. That means what? This capital V is what? Phasor voltage. All the 3 currents are what? Phasor currents. Okay. Now for a resistor, current and voltage will be in phase. So angle of I1 is equal to what? Angle of V. And for a capacitor, current will lead the voltage by 90 degrees. That means angle of I2 is equal to what? Angle of V plus 90 degrees. Yes. So from these two, don't you agree that angle of I2 is what? Angle of I1 plus 90 degrees. That means I2 leads I1 by 90 degrees. Whether I2 leads I1 or I2 lags I1, the important point is what? I1 and I2, both the phasors have an angle of 90 degrees between them. So what is the angle between I1 and I2? 90 degrees. So are they not 2 perpendicular phasors? Yes, on I1 and I2 in the phasor diagram, they are going to be perpendicular. And then what is KCL here? So if you write KCL at this point, I3 is what? Entering, I1 and I2 both are leaving. So don't you get I3 is equal to what? I1 plus I2. So this I3, is it not sum of 2 phasors which are perpendicular to each other? If you are adding 2 phasors which are perpendicular to each other, then the resultant phasor will have a magnitude which is same as what? The length of the hypotenuse. So you can think of the two perpendicular phasors, that is what I1 and I2, as the two sides of a right triangle. Yes, probably like this. So if this is I1, if this is I2, then this is going to be I3. This is the point I am trying to make. Okay. So I1 and I2 are like the two sides of a right triangle. I3 is like the hypotenuse of the right triangle. Yes. And you know, mod I3, what is it? Mod I3, will it not be equal to square root of mod I1 square plus mod I2 square? Yes. Now already we know mod I3. What is mod I3? It is 13. So in place of mod I3, let me write 13 is equal to square root of mod I1 square. I1 RMS is what? 5. So mod I1 squared, would it not be 25? Yes. And then we have mod I2 squared. That's all. If you square it on both the sides, 13 square is what? 169. 169 minus 25 is what? 144. Square root of 144 is what? 12. So what is mod I2? It is 12 amperes. That's all. So the reading on the ammeter A2 is going to be 12 amperes. I mean, it's very straightforward. Just like that, we can say that I2 has to be 12, because the only thing you should note from this circuit is that I1 and I2 are going to be perpendicular, and I3 is what? I1 plus I2. You just have to imagine this right triangle. For a right triangle, if you know any two sides, you can always find the third side. So it's like finding the third side in this right triangle. Already two sides are given. I hope this problem is clear. Okay. Okay, look at this. Is it not a series RLC circuit? Because clearly we have the resistor, the inductor and the capacitor all connected in series across a sinusoidal voltage source whose value is what? 100 volts. Whose value is what? 100 volts. In fact, you can think like this. Okay. Across the resistor, a voltmeter is connected, which is what? V1. Across the inductor also an AC voltmeter is connected, which is V2. Across capacitor also an AC voltmeter is connected, which is V3. So what are these V1, V2 and V3? They are three ideal AC voltmeters. V1, V2 and V3 are what? Ideal AC voltmeters. Just like AC ammeter would measure the RMS value of the current, AC voltmeter will measure the RMS value of the voltage. So V1 will read what? The RMS voltage across the resistor. V2 reads what? The RMS voltage across the inductor. V3 will read what? The RMS value, the voltage across the capacitor. Already the reading on V1 is what? 80 volts. Reading on V2 is what? 40 volts. That means the RMS voltage across the resistor is what? 80 volts. RMS voltage across the inductor is what? 40 volts. The question is what? What is the RMS voltage across the capacitor? In other words, what is the reading on the AC voltmeter V3? And this 100 volts is also what? The RMS value of the source. 100 volts is what? The RMS value of the voltage source. Okay. You see, first of all, ideal voltmeter will behave like what? Open circuit. Even though I have drawn the voltmeters here, if they are ideal, they will behave like what? An open circuit. So all voltmeters are what? Going to be ideal, which means what? R, L and C are still going to be in series. Even if you connect the voltmeters, they will simply measure the voltage without, drawing any current, because they will behave like what? An open circuit. So what is same for all the three elements? Because all three elements are in series, they will have the same current. Yes. For a resistor, the voltage and the current will be in phase. For inductor, voltage leads current by 90 degrees. For capacitor, the same voltage will lag the current by 90 degrees. So among the three voltages, which is the most leading voltage? Among the three voltages, V1, V2 and V3, please comment in the chat box, which is the most leading voltage. Among the three voltages, V1, V2 and V3, which is the most leading voltage? Just type whether it is V1 or V2 or V3. V2, very good. Which is the most lagging voltage? V3, very good, very good. You see V2 and V3, what you said is correct. V2 and V3, are they not 180 degrees out of phase? Yes or no? V2 leads V1 by 90, V1 leads V3 by another 90. So combining these two, we can say V2 leads V3 by 180 degrees. That means angle of V2 minus angle of V3 is equal to what? 180 degrees. Is equal to what? 180 degrees. And also, can't we write KVL around this loop? If you write KVL around the loop, won't you get Vs is equal to what? V1 plus V2 plus V3? Yes or no? Vs is equal to what? V1 plus V2 plus V3. Yes. Already mod Vs is what? 100 volts. Okay. And mod V1 is what? What is mod V1? It is 80 volts. Now V2 plus V3. So can you tell me what should mod V2 plus V3 be? What is the value of mod of V2 plus V3 is supposed to be? So you have to imagine the phasor diagram. Okay. Please look at the screen. V1 is what? The voltage across the resistor. Let it be like this. Let this be V1. V1 is what? Voltage across the resistor. Let it be along the positive real axis. You know V2, which is the voltage across inductor, will lead V1 by 90 degrees. So will it not be like this? Let this be V2. V3, which is the voltage across the capacitor, will lag voltage across resistor by 90 degrees. That means V3, it will be like this. Now what is this V2 plus V3 going to be? V2 plus V3. So if you are adding V2 and V3, are we not adding two phasors which are pointing in opposite direction? If you are adding two phasors which are pointing in opposite direction, then the magnitude of the resultant phasor will be the difference between the longer phasor and the shorter phasor. Yes or no? If you are adding two phasors which are in opposite direction, then the magnitude of the resultant phasor or the magnitude of the sum of the two phasors will be what? The magnitude of the longer phasor minus the magnitude of the shorter phasor. And what is the direction of the resultant phasor? Direction of resultant phasor will be in the direction of the longer phasor. Already mod V2 is what? 40. Already mod V2 is what? 40. You see. So the resultant phasor, that is what? V2 plus V3 will either be in the upward direction, that is what? Along the positive imaginary axis, or along the negative imaginary axis. I am just giving you two options, okay? So V2 plus V3 will either be in the direction of V2 if V2 is longer than V3, or it will be in the direction of V3 if V3 is longer than V2. Yes, but right now we are not even thinking about which one is longer. We can decide, but let's not worry about which one is longer. But for sure we know V2 plus V3, because both the phasors are in opposite direction. V2 plus V3 will either be along the direction of V2 or along the direction of V3. Whether it is along V2 or along V3, would it not be perpendicular to V1? So the point is what? V2 plus V3 and V1. V2 plus V3 and V1 both are perpendicular. So if you are adding V1 and V2 plus V3, listen carefully. If you are adding V1 and V2 plus V3, is it not like adding two perpendicular phasors? If you are adding two perpendicular phasors, then the length of the resultant phasor, what is the resultant phasor? Is it not Vs? Yes. So if you are adding two perpendicular phasors, then the resultant phasor is like the hypotenuse. So what is the length of the hypotenuse? 100. length of the hypotenuse is what? 100 units, okay? Already for the right triangle, one side is what? 80. We have a right triangle whose hypotenuse is what? 100 units, and one of the sides is what? 80 units. What should be the length of the other third side? Hypotenuse is what? 100. One side is what? 80. What should be the length of the third side? Please tell me. 60. Only 80 and 60 will give you what? A hypotenuse of length 100. That means mod V2 plus V3, it must be 60. Yes or no? The resultant phasor, when we add V2 and V3, it should be 60 units long. So that 60 and 80 perpendicular will give you a resultant phasor whose length is going to be 100 units. You understood? Now already V2 is how many units long? V2 is what? 40 units long. Yes or no? V2 is what? 40 units long. Now V2 plus V3 should be what? 60 units long. Can you tell me what is V3 supposed to be? First you tell me which one should be longer, V2 or V3? V2 or V3? Which one has to be longer? Use logic. You see V2 plus V3, that resultant phasor should have a length of 60 units. Already V2 has a length of 40 units. So between V2 and V3, which one has to be longer? Please tell me whether V2 should be longer or V3 should be longer. V3 should be longer. Yes or no? V3 should be longer because mod of V2 plus V3 will be what? Longer minus shorter. You are not adding the two lengths. You are subtracting the smaller length from the longer length. Yes, already one length is what? 40. And the difference should be what? 60. Difference should be 60. When will the difference be 60? When the other one is what? 100? Yes or no? So that 100, if this is what? 100 units, this is what? 40 units. 100 minus 40, you will get the required 60. You understood? That's all. That's all. So here, if V2 is what? 40, this should be, this should be 100. This should be 100. If this is 100, this is what? 40 units. The resultant, would it not be along V3? The resultant would be what? Along V3, and it will have a length of 100 minus 40. Longer minus shorter. 100 minus 40 is what? 60. So now this is what? 60. This is what? 80. 60, 80 perpendicular. Resultant will have a length of what? 100. That's all. So what is the mod V3? So what is mod V3? It is 100 volts. In other words, the reading on the voltmeter V3 is going to be 100. So once you imagine things in the phasor diagram, or once you visualize the phasor diagram, if you cannot visualize, you can draw the phasor diagram. You can make a rough sketch of the phasor diagram. Then you will understand, what is the angle between various phasors and so on. From there, we can immediately write V3 should have a length of 100 units. Okay.